Question 14. A curve C has parametric equations x equals 3 plus 2 sine t and y equals 4 plus 2 cos 2t, where t is more than or equal to 0 but less than 2 pi. Part A asks us to show that all points on C satisfy y equals 6 subtract x subtract 3 squared. Let's remind ourselves first of some of the double angle identities for cos 2t. So we want one that involves sine t. That will be useful to us. So cos 2t can be written as 1 minus 2 sine squared t. So that's a double angle identity for cos. The reason we've chosen that one is because x has got a sine t in it, and that will allow us to combine these two. So this implies that y will be equal to 4 plus 2 lots of this. So we simplify that, we get y equals 4 plus 2 subtract 4 sine squared t, multiplying out our brackets. Y equals 6 subtract 4 sine squared t. Now if we look to the equation for x, now x is equal to 3 plus 2 sine t. So if we make 2 sine t the subject, so we get x subtract 3 is equal to 2 sine t. Now if I square everything, so x subtract 3 squared would equal 2 sine t all squared, and thus we get x subtract 3 squared would be equal to 4 sine squared t. And that is what we've got here. So this all implies then that y is equal to 6 subtract x minus 3 squared. Part B, sketch the curve C. So we need to sketch y equals 6 subtract x minus 3 squared. So what kind of curve is that? So that looks like a quadratic, and because we've got the negative in front of what would be the x squared, it's a negative quadratic. So it's going to be a parabola in this sort of shape. So it's going to have a maximum point. Now if we remember from completing the square, this idea, we can find the maximum point from this. So the maximum point will be when x is 3, so we make this thing that's all squared, we make that equal to 0, and then what we'll be left with is 6. So 3, 6 is the max point of your quadratic, so that will help us to sketch it. We also need to consider the fact that it's a parametric equation. So because t goes from 0 to 2 pi, this is a full cycle of sine and cos. So if we consider sine t will go between 1 and negative 1 in a full cycle. So if we put that into our x, so x will be equal to 3 plus, so if it's the maximum value, it will be 3 plus 2 times 1, which is 5, and x will be equal to 3 plus 2 times minus 1, which is 1. So it's important to realize here that our range of values for x is going to be between 5 and 1 when we're drawing our sketch. So when x is 1, what would y be equal to? So I'm going to use 6 minus, so we're going to put 1 in there, so 1 subtract 3 squared. So that makes 1 subtract 4, which is 2. And if I put x equals 5 in here, y will be equal to 6 minus 5 subtract 3 squared, which again is also 2. So we've got 1, 2, and 5, 2 as our sort of start and end point, and we also know the maximum is at 3, 6. So that's going to allow us to draw our sketch. So we're going to draw our set of axes. Now I advise you use a ruler and pencil, and then I'm going to label these points. So always label your axes. So we've got 1, 2. We've got 3, 6. And then we've got, so 3 is nicely in the middle of this 1 and 5, and then we've got 5, 2. So it's a parabola, and so the maximum's here, so we're going to get this sort of shape, something like this. So for part II, we just need to explain what we kind of already have. So as sine t is going to be between 1 and negative 1, x will therefore be between 5 and 1. We have a restricted domain, you could say. So we do not include all values for x in the set of real numbers. The line with equation x plus y equals k, where k is a constant, intersects C at two distinct points. So we have this equation intersects the curve at 2 points. State the range of values of k, giving your answer in set notation. So let's consider this. So x plus y is equal to k. So if we make y the subject, that's y equals negative x plus k. Now I know what negative x plus k roughly looks like. It's a straight line with a negative gradient, and it's going to go through at k. So I'm going to draw just some examples of what this might look like. So for example, if it looked like this, it's not going to cross the curve at all. There'll be no intersection points. If I drew it here, I can see here they've got one intersection point. If I draw it a little bit above there, I can see that if it goes through the bottom point here and here, I'm going to get two intersection points. So that's going to be crucial. So if I can get our curve to cross at this 5, 2 point, that's going to give us two solutions. The other option, if I go higher than it, so if I went over here, there's no solution. So I need it to be this side. So it needs to be this side of sort of just touching the curve. So I can create some inequalities with that idea. First of all, I'm going to try and see a straight line that goes through this point 5, 2. I know that y equals negative x plus k. So if I put 5, 2 in here, x equals 5, y equals 2. I'm going to sub these into this y equals negative x plus k. So we get 2 equals negative 5 plus k. So add it over, we end up with k equals 7. So if my straight line here was crossing up at k equals 7, you can see that anything above there is going to intersect twice. So from that, I can get a lower part of my inequality. I need that x has got to be larger than or equal to 7. If it does cross exactly at that point, I will get two solutions, so it can be equal to 7. For the other side of our inequality, we can apply the discriminant and our rules about the discriminant with quadratics. So we know if we get more than one solution, more than two intersections, that tells us that b squared minus 4ac is larger than 0 if you get two solutions. So we have y equals negative x plus k. And we also have y equals 6 subtract x minus 3, x subtract 3 squared. So if I solve these simultaneously, put them equal to each other, so negative x plus k, 6 subtract x minus 3 squared. I'm going to multiply out the brackets, we get negative x plus k to 6. So multiply out the brackets, and do it up here, so x subtract 3 squared equals x squared subtract 6 x plus 9. So we're going to get subtract x squared plus 6x subtract 9. I'm going to bring this all over to one side. We want our quadratic equal to 0, so I'm going to get positive x squared, negative x, so negative 7x, and then plus k. 6 subtract 9, so we get plus 3 equals 0. Now this equation, the discriminant should be larger than 0 for this to get two solutions. So what I like to do is just label, so my a is 1, my b is negative 7, and my c here is going to be k plus 3. So we put this all into the discriminant equation. So we're going to get, this will imply that negative 7 squared subtract 4 multiplied by k plus 3, and this should all be larger than 0. So we're going to get 49 subtract 4k subtract 12 is going to be larger than 0, and then we're going to get 37 is larger than 4k. So finally, our inequality we'll get is 37 divided by 4 is larger than k, or k is less than 37 over 4. So if we bring these two together, so we've got this and we've got this, and we need to give our answer in set notation. So our set of values for k, so it needs to be greater than or equal to 7, but less than 37 over 4. And if you imagine those straight lines with k as your y-intercept, so if it's above 7, it would meet this bottom point here, and if it was below 37.4, it would just be below where it makes a tangent, and we get those two intersections. So that's another 10 marks on question 14. So I think that's probably the trickiest question on the paper, that one.